Okay, now I want to solve here a full circuit with a battery, a bunch of resistors, and we're going to completely solve the circuit, which means that we're going to find out all of the currents in the circuit and all of the differences in potential on the elements of the circuit. So that's what it means to solve it completely. So I have a 3 ohm resistor here. Then that's connected to this 6 and 12. This is 18 ohms. The battery has an EMF of 12 volts. Let's talk about different points, A, B, and C. Okay. So as I said, we want to find all the delta V's and all the currents. I should put it in there. All right. So how do we proceed? What will be the next step to take? So what you're after is to find the net resistance, the equivalent resistance of the circuit, right? Because if you know the equivalent resistance of the whole circuit, the first current that you're going to be able to find easily is the current that goes out of the battery. Because that current will be 12 divided by whatever your net resistance for the circuit is. Okay? And once you have that current, then you can continue to try to find the other currents and other voltages and so on. So the first thing that I would do is, as he said, find the equivalent resistance of the circuit. And to find the equivalent resistance of the circuit, you always start by trying to simplify the circuit, trying to find 2 resistors or more that are clearly in series or in parallel. Right? So he's saying 6 and 12 ohms, they are in series. They're connected along one single branch. Okay? So I can replace those 2 with 18. Right? So the equivalent resistance of those 2 is 18. This 2 have an equivalent resistance of 18 ohms. What do I do now? What do I do next? Now that those 2 have a resistance of 18, I replace them with 1. And is that one resistor with 18 ohms resistance, is that connected in series or in parallel to the other 18 ohm resistor in the circuit? They're clearly in parallel. So now you're going to do 18 in parallel with 18. Okay, so the first step was 6 plus 12 equals 18 ohms. That's the resistance up there. Now we're going to do 18 ohms connected in parallel with 18 ohms. Right? So how much is that? 18 in parallel with 18. 9. That's right. Whenever you have R in parallel with R, the net resistance is R divided by 2. Right? You can do R times R divided by R plus R. The answer is R divided by 2. So this is going to be 9. 9 ohms. So 9 ohms is now the equivalent resistance of these 3 resistors taken together. Now those 3, once you replace them with 9 ohms, those 9 ohms are now in series with the 3 ohm resistor, right? So now the whole thing is going to have a total resistance of 3 ohms plus 9 ohms. That is 12 ohms. And that is the resistance of the whole set of resistors. So now the current, which was the first step that we thought we could get after the equivalent resistance was found, would be 12 ohms divided by the net resistance of the circuit, which we just figured out is 12 ohms. So the current in the circuit is now 1 amp. We know that that is the current coming out of the battery, that goes out of the positive terminal of the battery. Okay, next step. So we know the difference in voltage of the battery and we know the current through the battery. Now we move on to another element of the circuit and try to figure out the current and the difference in voltage. We know the current, 1 amp flowing out of the battery. You might want to follow that current and see if it allows you to find something else. That current is going to go through the 3 ohm resistor, right? So what do I know about the difference in potential across the 3 ohm resistor? It should be how many volts? Say it again. Negative 3 volts. If you move with the current, then you should be going from high ground. So I'm going to put a little plus to indicate that this is the highest potential side of the resistor, and this is the lowest potential side of the resistor. And as you move across that resistor, your difference in potential is going to be the current times the resistance with a minus sign. So delta V at the 3 ohm resistor is going to be minus Ohm's law, right? The current going through that resistor, which is the same as the current going through the battery, multiplied by 3 ohms, which is the resistance of that resistor. So that is minus 3 volts. Okay? We know the current through that resistor and we know the voltage of that resistor, so we're done with that one. We know all the information about that resistor. So now we move on to another one. What would be a good candidate to calculate the current or the difference in voltage?
Since we calculated that the total resistance of the second part of the group of resistors, and we found out that was 18 ohms, so then we could just use that and try to figure out the second change in voltage.
This whole group over here, I'm going to point at it. Okay, this whole group of resistors, which is this one, and that one, this whole thing has a resistance of 9 ohms.
Oh, 9 ohms.
Right.
So then, yeah, you would use that to figure out the change in voltage, which would just be negative 9 volts.
Yeah. That's right. That's what I would do. So notice that as you move from here to here, you went up by 12 volts. As you move from here to here, you drop by 3 volts, right? So now what's your height? If you say that this is 0 height, you went 12 here and you drop 3. So what's your height over here? That should be 9, right? And this is 0 again over here. So the difference in potential between this point and that point is negative 9 volts, right? Flowing in the direction of the current. That will be going from high ground to low ground. Your change in height will be minus 9 volts, right? So we do know that the difference in potential between B and C is minus 9 volts, right? So we can write that down, and that's going to allow us to calculate the rest of the stuff for the 6, 12, and 18. So I'm going to have to erase somewhere. So let's write that. The difference in potential between point B and C should be equal to, we just said, minus 9 volts. Correct? Okay, so if that's minus 9 volts, what is the current flowing through the resistor 18 ohms? The current flowing through the 18 ohm resistor should be equal to what? That's right. Minus delta V divided by the resistance, which is 18 ohms. So that is minus with minus 9 volts over 18 ohms. That should be 0.5 amps. And the current flowing through the 6 ohm resistor or the 12 ohm resistor should be the same, right? So because 0.5 ohms are going down, and we know that there is 1 ohm flowing over here. So what the 0.5 difference between them is 0.5. That's the amount of current that must be flowing on the top. Okay? So the current flowing through the 6 ohm resistor is going to be equal to the current flowing through the 12 ohm resistor. And that current is going to have to be equal to 0.5 amps, right? Because, let me spell that out for later when you look at it. Because that current is going to be equal to I, the total current, minus 0.5. And we know that that's 1 amp minus 0.5, 0.5. Okay. The only thing left to do is calculate the difference in potential across resistor 6 ohm and the difference in potential across 12 ohm resistor, right? And then we'll be done because we'll know all the currents and all the differences in potential. The difference in potential between B and C is 9. No, actually, we know the current, which is 0.5. So what's the difference in potential across the 6 ohm resistor? That's just Ohm's law, which says delta V is going to be I times R, right? So the current is 0.5 multiplied by 6. That's 3. So 3 volts negative is going to be the difference in potential across that resistor. So I'm going to write it over here. Delta V for the 6 ohm resistor is going to be minus 6 times the current minus 3 volts. And the difference in potential across the 12 ohm resistor, 0.5 times 12, which gives you 6. Or you can say delta BC is 9. 3 of those 9 are falling through the 6 ohm resistor. Then the other one must have the rest, the remaining 6. Right? The total is 9. 3 over here. From here to here is 9. We just calculated that from here to here is 3. Therefore, from here to here must be 6. All right. So that's the last computation there. I should write it somewhere. Delta V 12 ohm is equal to minus 6 volts. We have all the information about that circuit.